Like, subscribe, and hype the video. Also, leave a comment on any topics you want to hear about in the future. Okay, let's dive in. In our last episode, we walked through the extraordinary scientific achievements of the Voyager missions, the volcanic moons of Jupiter, the ring architecture of Saturn, the bizarre geology of Uranus's moon Miranda, the active geysers of Triton, and the historic crossing into interstellar space. It's one of the greatest scientific programs humanity has ever run. But as Voyager traveled further and further from the Sun, something strange started showing up in its data. Anomalies. Readings that didn't quite match what the models predicted. And those anomalies have generated both legitimate scientific investigation and a parallel conversation in conspiracy communities about what Voyager has actually encountered out there in the darkness between the stars. Today, we're walking through all of it, the real documented anomalies, what scientists actually think caused them, and where the wilder theories take things from there. Before getting into the Voyager anomalies specifically, it's worth understanding a related mystery that preceded them and set the stage for much of what followed: the Pioneer Anomaly. Pioneer 10 and Pioneer 11 were spacecraft launched in the early 1970s, slightly before Voyager, on trajectories through the outer solar system and eventually into interstellar space. As they traveled further from the Sun, scientists tracking their precise positions noticed something unexpected. Both spacecraft were decelerating very slightly more than the known forces of gravity, solar radiation pressure, and other calculated effects could fully account for. The deviation was tiny, roughly equivalent to the gravitational pull of a paperclip on a person, but it was real, persistent, and reproducible across decades of measurements. This became known as the Pioneer Anomaly, and it attracted serious scientific attention for decades, precisely because it couldn't be immediately explained. Some researchers speculated it might indicate a modification to the laws of gravity at large distances from the Sun. Others proposed it as evidence for dark matter interactions. The mystery remained genuinely open for years, feeding significant speculation both within the scientific community and in online conspiracy circles. The eventual resolution, published in 2012 after an extensive analysis of thermal data from the spacecraft, was considerably less exotic than the speculative explanations. The asymmetric emission of heat radiation from the spacecraft's own electronic components was creating a tiny but consistent thrust in the direction of the Sun, an effect called anisotropic thermal radiation pressure. It was small enough to be negligible for most purposes but large enough, accumulated over decades of precision tracking, to produce a measurable deviation. A mundane thermal effect, not new physics, not dark matter, and not anything encountered in deep space. Like, subscribe, and hype the video. And now let's get into what Voyager itself actually found. When Voyager 1 crossed the heliopause in 2012, the instruments on board were designed to measure exactly what happened at this never-before directly sampled boundary, and what they measured surprised heliophysicists in several specific ways that have driven significant scientific research since. The transition was not the smooth, clean boundary that simpler models had predicted. Instead, Voyager detected a complex layered structure, multiple distinct regions with different particle and magnetic field characteristics, rather than a single sharp line between solar and interstellar space. Cosmic ray intensities increased in step-like jumps as Voyager approached the boundary rather than rising smoothly. The magnetic field direction at the heliopause remained largely unchanged across the boundary, oriented similarly on both sides, which contradicted some models that had predicted a more dramatic rotation in magnetic field direction as the spacecraft crossed from solar wind into interstellar medium. These surprises were genuine and scientifically significant, not in the sense of suggesting unknown forces or alien encounters, but in the sense that they revealed real gaps in our theoretical models of how the heliosphere interacts with the interstellar medium. Papers published by the Voyager science team in Science and Nature described the crossing as revealing a more complex boundary structure than anticipated, and the data has been driving revised theoretical models of the heliosphere ever since. The science was surprising, it was also completely openly published immediately. Here's where the Voyager story moves from genuine scientific surprise into the conspiracy territory that circulates online. And it's worth walking through the main claims carefully because some of them borrow the language of real scientific findings while taking them in unsupported directions. The most common claim is that Voyager has detected or encountered something in interstellar space, a signal, a structure, or evidence of another civilization that NASA is aware of and actively suppressing. This claim typically surfaces around genuine news stories about Voyager data anomalies, taking the real scientific uncertainty and extending it into far more dramatic territory than the actual data supports. The problem with this claim is the same one we've encountered in every suppression theory throughout this series. Voyager's data is public. NASA's Jet Propulsion Laboratory publishes Voyager mission status, trajectory data, and scientific findings continuously and openly. The raw science data is available through NASA's Space Physics Data Facility. Multiple international research teams work with Voyager data independently of JPL. If there were a confirmed anomalous signal or encounter of the kind conspiracy theories describe, it would be in the data, publicly accessible data, that independent researchers worldwide are actively analyzing. Like, subscribe, and hype the video, and let's talk about one specific anomaly that generated the most dramatic coverage. In 2022, the Voyager 1 mission generated a genuine and widely covered mystery that fed a significant wave of speculation online. The spacecraft began sending back corrupted telemetry data from its attitude articulation and control system, the computer responsible for keeping the spacecraft properly oriented. The data was being received on Earth, but it didn't match any expected pattern and appeared to show no correlation with Voyager's actual state or commands being sent to it. For several months, engineers at JPL worked through the problem remotely, communicating with a spacecraft over 23 billion kilometers away, where each command takes over 22 hours to arrive, and each response takes another 22 hours to return, giving a round-trip communication time of nearly 2 days for every single diagnostic attempt. The patience and systematic methodology required for this kind of remote troubleshooting is genuinely extraordinary. The eventual diagnosis, announced in 2023, was that a single chip in the flight data system computer had failed, corrupting a specific section of memory that the attitude control computer was using to store and transmit its data. Engineers devised a software fix that rerouted the affected code around the faulty chip, restoring normal telemetry from the attitude control system. A hardware failure in a 46-year-old computer operating over 23 billion kilometers from Earth, diagnosed and fixed remotely by a team of engineers, not an alien signal, not a mysterious encounter, but one of the most impressive acts of long-distance engineering troubleshooting in the history of space exploration. Even as its power slowly fades, Voyager continues returning irreplaceable scientific data. Both spacecraft carry working instruments measuring magnetic fields, cosmic rays, and plasma waves in interstellar space, data that no other instrument in history has ever been able to collect from this location, and that no planned future mission is currently scheduled to reach for decades. The plasma wave instruments are particularly valuable, having detected the density of the interstellar medium directly for the first time, a measurement that had previously only been estimated from indirect observations. Voyager 2's crossing of the heliopause in 2018, which happened in a different direction from Voyager 1's crossing, is providing scientists with comparative data showing how the heliosphere's boundary varies depending on direction, revealing asymmetries in the structure of our solar system's protective bubble that weren't previously measurable. When the last instrument finally falls silent, projected for the late 2020s as the radioisotope thermoelectric generator's power output drops below the minimum operating level, both spacecraft will continue silently into the galaxy. In roughly 40,000 years, Voyager 1 will pass within about 1.6 light-years of a star called Gliese, 445. In 296,000 years, Voyager 2 will pass within 4.3 light-years of Sirius, the brightest star in our night sky. Neither spacecraft will stop. Neither will slow down. They'll drift through the galaxy indefinitely, the longest-lasting artifacts of human civilization, carrying golden records encoded with the sounds and images of Earth, drifting forever through the space between the stars. So here's the real story of the Voyager missions: 47 years of continuous operation, the only close-up observations ever made of Uranus and Neptune, the first human-made objects to cross into interstellar space. Genuine scientific surprises at the heliopause that are still driving new research. A 2022 hardware failure diagnosed and fixed from 23 billion kilometers away, and a final journey into the galaxy that will outlast every other artifact of human civilization by hundreds of thousands of years. The conspiracy theories surrounding what Voyager has encountered out there don't survive contact with the openly published, publicly accessible data the mission has been producing continuously for nearly 5 decades. But what Voyager has actually found, and continues to find, is more extraordinary than any of those theories, and it's all sitting in the public record, available to anyone who wants to look. If you've made it through both episodes, let me know in the comments what you find most extraordinary about the Voyager story. Like, subscribe, and hype the video, and I'll see you in the next one.